Okay, this is an introduction to Chapter 2. Chapter 2 is going to deal with water, okay? Water and why it is so important in biology. Now, keep in mind, in your chemistry courses, you have used different solvents depending upon which chemical reaction you wish to study, which chemical reaction you wish to replicate. But here in anything that's bio, straight biology, biochem, anything that deals with life, deals with the cell, water is going to be our solvent of choice. Everything that we study is going to be a reaction in water. Okay, we're not going to look at how it reacts in an alcohol solution, how it reacts in whatever. Water is what we focus on. Because think about it, as you sit there listening to this, you are trillions of bags of water, or aqueous solution, I should say. So, anything we're going to study in a biochemistry, biology, microbiology, cell biology, genetics, how's this reaction occur in water? Now, what we need to also look at is how this solvent ability of water does occur, okay? Because it's not just you put stuff in water, things happen, ta-da. No. The properties of water deal with the fact that it is a somewhat polar molecule. It does have dipole attributes to it, because remember, the oxygen with the two hydrogens that are off on their angles, the oxygen, which is going to be a greedy little bugger, even though it is covalently bonded to the two hydrogens, it is an uneven sharing of the electron pair. Thus, more often than not, the oxygen is going to have 2 electrons in its orbit more than it has protons. Thus, it has a negative-ish charge. The 2 hydrogens, more often than not, are just going to be 2 protons out there. Every so often, those electrons will return from oxygen orbit and then go back to oxygen, because it is a bigger atom, thus it has a greater pull on those electrons versus just the individual protons that make up the nucleus of hydrogens. So you have a negative-ish oxygen end, 2 positive-ish hydrogen ends. Dipole. We call water a polar molecule because it has an inherent charge-like attribute. It's not truly charged, not like sodium and chloride, which, sodium always positive, chloride always negative. But it's this positive-ish, negative attribute to water that allows it to interact with all other water molecules in a given volume. We refer to this interaction as hydrogen bonding. The positive-ish hydrogen, the negative-ish oxygen of a neighboring water molecule are going to be attracted towards each other. Positive, opposites attract. Now, because of this, along with the fact that water has a tendency to dissociate, the molecule itself, not all of the hydrogen bond, the water itself has a tendency to fracture, break apart. OH, hydrogen, forming ions. Okay. We're going to see later in this chapter that dissociation that it has means that, it has the ability within it for there to be changes in hydrogen concentrations, changes in free hydroxyl concentrations. Change in free hydrogen. Take an inverse, the logarithmic of that concentration, and oh my gosh, you have pH. So we're going to see how this comes into play with pH. We're also going to see that in a biological system there seems to be a range where everything wants to occur. Yes, you have the whole pH range, but it's this very narrow band that things can occur within our cells. Yes, somewhere in your body can you find things down to the bottom, pH 2, 3, 4, sure. Stomach contents, in certain acidic organelles within your cells. Can there also be up at the top range? Yes. But for the most part, things are going to occur within this narrow band. And some of the attributes of water are there. They aid in maintaining this narrow band of pH to allow the chemical reactions in our bodies, in our cells, to occur. And we're also going to look at and discuss the fact that even though polypeptides and proteins, for the most part, are going to be composed of either, hydrophobic amino acids or nonpolar or something along those lines, amino acids that really do not want to interact with water, the overall protein itself is going to interact with the water at the molecular level to force the proteins, force our enzymes in our cells to be in solution. And we're going to discuss how that occurs.